Welcome to digital classes. Children, in our previous classes, we have learned about the chapter heat, and in today's session, let us see what we are going to learn more about heat. Children, in today's lesson, we are going to learn some important phenomena connected with the concept of heat and temperature. We are going to learn about evaporation, the process of condensation, what is humidity, dew and fog, boiling, freezing and also melting. So, children, before going into today's class, let us review what we have learnt in our previous class. We have learned about the concept of specific heat. So, children, we have seen specific heat of a substance is the amount of heat required to raise the temperature of unit mass of a substance by 1 unit. That is, if we want to raise the temperature of a substance by 1 degree Celsius and the mass is 1 gram, how much amount of heat is required for such a kind of heating? This is called as specific heat. The next point, the specific heat value is different for different substances. This also we have seen, children. The specific heat of water we have seen is the largest value. Water takes the maximum time to get heated up. At the same time, water can retain heat for a very long time. That this specific heat depends upon the sharing of heat energy among different types of internal energies. What are the different types of internal energies, children? Yes, in the previous session we have discussed about this, that the energies shared by the molecules inside can be kinetic energies, rotational energies, vibrational energies, and whatever heat we are supplying to the liquid or to the substance is divided in certain ratio among these different kinds of energies. Depending upon how this energy is shared is the value of the specific heat. So, next, children, we have seen the principle of method of mixtures. That is, if we try to combine two or more substances which are at different temperatures, then the final temperature of the sample is given by T is equal to M1 T1 plus M2 T2 by M1 plus M2. And in general, the principle of method of mixture says that the net heat lost by the hot body is equal to the net heat gained by the colder body. So, children, this was what we have learnt in our previous session. Now, before actually talking or discussing about today's topic, let us look at a few images. Clothes drying under the sun, what we do every day, children? Yes, we wash clothes and dry it in the sun preferably. So, here you can see, children, some vapors coming out of the clothes. Yes, we know that whatever water is contained inside the clothes get dried up because of the sun or because of the air. Next, we all sweat during summer season, or when we have played a lot, when we have walked a lot, we all know we have sweat being exerted from our body. Now, this sweat also tends to get evaporated from the surface of our skin. How do you feel, children? Yes, when we are sweating and sweat is getting evaporated, we feel a bit cooler. Keep this in mind, children. Now, children, let us take a small drop of spirit. Do you know, children, what spirit is? Yes, it is available with the doctor. The doctor usually rubs it on our hand before giving us injection, or you can also take a few drops of nail polish remover and put few drops on your hand. What do you observe? Yes, in no time the droplets of the spirit or the remover will be vanished or will be evaporated, leaving a cool feeling on our hands. So, children, what did we observe in all these three images? Yes, in all these three images, the common point was the evaporation. So, evaporation, children, we know in general is the process in which a liquid is getting converted into its gaseous form. So, the process of escaping of molecules from the surface of a liquid at any temperature is called evaporation. What happens during the process of evaporation? During the process of evaporation, energy of the molecules inside the liquid decreases and they slow down. So, inside the liquid, what is happening? The molecules of the liquid are in continuous motion. When they are in continuous motion, then they exchange while moving, they collide and they exchange their energies with their neighboring molecules. So, in this way, some of the molecules which remain inside the liquid, they lose their energy, and the molecules that gain in energy are getting evaporated by reaching the surface. The next point is the energy is transferred to the escaping molecules. Yes, so where is the lost energy going? The lost energy is taken by the molecules that are escaping from the surface. Look at this image, children. You can see here the molecules inside the liquid, they are moving, they collide with each other, they exchange their energies, and some of them are escaping to the surface. So, this is how, children, the process of evaporation takes place. So, what is happening here? By increasing energy, some of the particles are escaping to the surface, but the particles that are remaining inside the liquid are losing out with their energy. In this way, their temperature will also come down. Since, children, last class we have seen temperature and kinetic energy are directly proportional to each other. So, if the energy is lost by the molecules of the liquid, then the temperature of the liquid overall decreases. Now, observe another image. In this image, you can see, children, when the particles are reaching the surface, as soon as they gain enough energy, they will jump out of the surface of the liquid in this way. They may go in different directions. There is always a possibility that the molecule of the liquid may jump back or come back to the liquid again. Under certain circumstances only, they are able to blow away or move away from the surface of the liquid. So, in this way, we say that evaporation takes place, which results in the liquid overall being cooled down, or we say that evaporation is a cooling process. Evaporation is a surface phenomena. We are saying surface phenomena because the process of evaporation takes place in the open surfaces. When you leave a glass of water open for some time and then observe, you will see that the level of the water decreases. So, we can say that evaporation takes place at the surface. Temperature of a system falls during evaporation. This we have seen with the reason, children, because the energies present inside the liquid, they are giving off the energies to the molecules that are getting evaporated. The loss of energy of the molecules results in the decrease in temperatures. So, that is how we say that evaporation overall is a cooling process. Now, children, what are the factors that will help evaporation to take place faster, or factors affecting the rate of evaporation? These are the 4 factors, children, that affect the rate of evaporation. The surface area, just now we discussed that evaporation is a surface phenomena. So, most importantly, the surface area, the humidity at the place, wind speed and temperature. Now, children, let us try to understand these 4 factors individually. Now, look at this image, children. We have 2 bowls of water or any other liquid. This is a bowl with larger surface area and this is a bowl with a smaller surface area. Evaporation takes place faster compared to in this case, because here if you see, children, it is a bowl with small surface area and it is a larger surface area. Children, have you ever noticed people drinking tea with the help of a cup and a saucer? You know, a saucer is provided along with the cup. What is the reason for having this saucer along with the cup? It is very simple, children. The cup has a smaller surface area. The opening of the cup is a smaller surface area, whereas the saucer has a larger surface area. So, when hot tea is poured into the saucer, it gets cooler faster than in the cup. So, this is the reason a saucer is provided with the cup, so that it helps the person to drink it more comfortably. So, hence we can say that evaporation takes place faster if the surface area is larger. Evaporation is a surface phenomena. Larger the surface area, faster is the evaporation. Hence, we say that rate of evaporation is higher for larger surface areas. The next factor, children, we are going to see is the humidity. Humidity is defined as the amount of water vapor present in air. Children, during rainy season, if you observe, there are a lot of water droplets present in the air in the form of water vapor. Water molecules present in air is called as humidity. So, during rainy season, it is more humid compared to summer and winter season. It is because of more and more number of water molecules present in the atmosphere. So, when it is humid, we have two images here, children. Look at the first one. Very less number of water vapor particles are present in the first image and the air is flowing freely. In the second image, we have more number of water particles present in the atmosphere and less air is moving here. Here, if the humidity is high, the rate of evaporation will decrease. The reason here is, children, already the air is filled up, the atmosphere is already filled up with enough number of water particles and there is very less space for other water vapor particles to join them. So, hence during humidity or during rainy season, it is very difficult for the clothes to dry faster, and during other days just like winter or summer, when there is less humidity, the clothes dry faster. So, if humidity is high, the rate of evaporation will decrease. This is how humidity affects the rate of evaporation. Higher the humidity, lower is the rate of evaporation. Lower is humidity, higher is the rate of evaporation. Now, let us look at the another factor, that is the wind speed. Isn't it common, children, that wind speed helps in the evaporation, the faster evaporation? Yes, when it is raining outside, we usually think of drying our clothes at home with full fan speed. Isn't it, children? Don't we do that? So, here if the nature is not cooperating, we take the help of our fan to dry our clothes in the wind. So, hence, children, wind speed helps to evaporate. Increase in wind speed causes the water vapor particles to move away with the wind. Higher wind speed helps in faster evaporation. Therefore, rate of evaporation is higher for a high wind speed and lower for low wind speed. When there is no wind, then the evaporation also takes a lot of time. The last point affecting is the temperature. As temperature increases, rate of evaporation also increases. This is a very common thing, children. On hot sunny days, water gets evaporated very easily. It is not just about drying clothes, children. We must have heard that big lakes and ponds also tend to get dried up during hot summer days. Here the phenomena taking place is evaporation again, and what is the reason? During high day temperatures, water tends to get evaporated from lakes and ponds, which results in the drying up of these lakes and ponds. Rise in temperature gives energy to surface particles to evaporate. So, when temperature increases because of the sun's heat, the particles present on the surface, they get enough energy, they get enough kinetic energy to escape into the atmosphere. In this way, because of higher temperature, rate of evaporation will also be higher. So, children, this was about evaporation. I hope you understood, children. Now, let us look at some more images. What do you see, children? Look at this image. This is the image of a water bottle which must have been taken out of a refrigerator. Here we have the image of blades of grass with tiny droplets of water. You can get to see such a sight, children, during winter mornings. You will see such a sight, right, children? So, we know that it didn't rain. We know that this bottle was just taken out from the refrigerator. Then how did these water droplets come here? Let us look at some more images, children. What is the kid doing? The kid is obviously sitting inside his home. Outside is definitely raining. Based on what he is doing, you can say. The kid is drawing some images on the window panes. which have been smogged. The inside of the car window pane is fogged up and it is obviously raining outside in both the cases. So, when it is raining outside, our window panes turn to be fogging up from inside. What is the reason for all these things, children? Condensation. The process involved in all these things is called as condensation. So, here condensation is exactly an opposite process of evaporation. The process of change of phase from gas to liquid is called condensation. So, evaporation we have seen, children, the liquid was getting converted into gas, and here it is a change of phase from gas to liquid. Condensation is a warming process. Just how evaporation is a cooling process, condensation is a warming process, which means that it leaves the substance warmed up after the condensation. What is happening during condensation? During condensation, the average kinetic energy of the gas particles decreases and they convert into liquid form. So, usually condensation takes place during colder temperatures, when water vapor particles accumulate around an object. Due to condensation, they come closer and closer together and they settle on the surfaces of the objects, hence they will get converted into liquid. From vapor form they will get converted into liquid. So, when this water bottle was kept outside, the water bottle is at a colder temperature compared to its surroundings. The air around the water bottle got condensed. The water vapor particles present around the water bottle got condensed and they turned into liquid droplets by settling on the water bottle. In this way, condensation takes place because of cooler temperatures. Once again, this is a familiar that you get to see during winter mornings. During winter mornings, we get to see water droplets on flowers. So, what is the reason behind this? During the winter nights, the temperatures fall, that is, the temperatures are very less during winter nights. So, the surface of objects become more colder due to this falling temperatures. The air near the objects becomes saturated with water vapor and condensation begins. The water vapor particles present around this flower, let us talk about this flower now. The water vapor particles present around this flower, they get saturated. This is called as dew drops, children. Okay, children, this is called as dew drops. This is a familiar image, children, yes or no? During winter mornings, when you take a stroll in your fields or you come out to the road, you cannot see the other side clearly. This is called as fog or pogamanchu. Take a look at this image, children. What is happening here? Yes, in this image water is boiling. Very familiar with the process of boiling. Boiling is a process in which the liquid phase changes to gaseous phase at a constant temperature and a given pressure. So, under constant atmospheric conditions like constant temperature and constant pressure, we see that water starts boiling. This temperature at which water starts boiling or the liquid starts boiling is called its boiling point. Different liquids have different boiling points. So, we are familiar with the boiling of liquids. We have seen the liquids boil like water and milk, but we also see bubbles being formed, especially in water. When water is boiling, a lot of bubbles are formed. Let us see the reason behind this bubble formation, children. Water, we know, children, is not pure in its form. Water contains many dissolved impurities. It is a very good solvent, children, and it can dissolve many things like impurities including gases. Some of them are desired and some of them are non-desired. When this water is heated, the solubility of the dissolved gases decreases. Okay, children, the gases are dissolved in water. When we are heating water, the solubility of these gases reduces and they are forming bubbles. The gases are forming bubbles when we are heating it. At a certain temperature, the pressure inside the bubble becomes equal to the external pressure. So, when such a situation arises where the bubble pressure and the external pressure become equal, the bubbles will reach the surface and they collapse at the surface, hence the impurity gas is liberated outside. In this way, the vapor inside the bubble is released out. This vapor inside the bubble is nothing but the impurity gas. So, children, I hope you understood why we are advised to boil water before consuming it or before drinking it, so that it helps to remove many kinds of impurities by boiling. Now, children, we have seen evaporation, we have seen boiling. In both these cases, liquid is getting converted into vapor. So, are these two concepts or are these two phenomena the same, or is there any kind of difference in between these two? Let us see. Boiling occurs at a definite temperature called boiling point, whereas evaporation takes place at any temperature below boiling point. So, this is a very remarkable difference between boiling and evaporation, children. In boiling, water or any liquid has a specific constant temperature at which only it starts getting vaporized, whereas evaporation can take place at any temperature below its boiling point. We have seen that liquids from the ponds and lakes are getting evaporated, but we have not seen them boiling, isn't it, children? So, the remarkable difference is the temperature. Boiling occurs only at a specific temperature and pressure, whereas evaporation can take place at any temperature below the boiling point. When boiling starts, temperature of the liquid cannot be increased further. This is a very important thing, children. When water reaches its boiling point, we know at 100 degrees Celsius it reaches its boiling point, but its temperature does not increase further, but temperature can be further increased till boiling point is reached for evaporation. So, these are the two main differences between boiling and evaporation. After the boiling point of the liquid is reached, there is no increase in the temperature. Then what is happening to the heat given? See this image, children. In this image, we are seeing a container with water placed on a stove. Heat is continuously being provided and the liquid is boiling, but there is no increase in the temperature. There is no increase in the temperature and vaporization is taking place. Yes, children. So, what is happening to the heat provided? Where is the heat energy going? Let us see. We know that boiling point of water is 100 degrees Celsius. Temperature does not increase further even if heat is supplied. So, where does the heat energy supplied go? This we are going to learn in the form of latent heat of vaporization. So, the heat energy supplied is used to change the state of water from liquid to vapor. The bonds of the liquid are broken and it is converting into vapors. So, this energy is called as the latent heat of vaporization. The heat energy required to change 1 gram of liquid to gas at constant temperature is called the latent heat of vaporization. It is denoted by capital L, latent heat of vaporization, and the formula is Q by M, where M is the mass of the liquid we have taken and Q is the amount of heat in calories required to change the liquid to its gaseous state. Once again note the formula, children. It is L is equal to Q by M and its units will be calories per grams or joule per kg. The CGS unit of L is calorie per gram, SI unit of L is joule per kg. We know that boiling point of water at standard atmospheric pressure is 100 degrees Celsius or 373 Kelvin. Latent heat of vaporization of water is 540 calories per gram. The next process we are going to see here is, children, the process of melting. When does melting take place? What do we call as melting? Yes, the conversion of a substance from its solid state to liquid state because of heat is called as melting. We know that ice melts into water at 0 degrees Celsius, but till the entire ice is converted to water, there is no change in the temperature. It keeps showing us 0 degrees Celsius. Look at this image, children. We have some ice cubes present in a glass of in a glass and it is already starting to melt, but the temperature shown is 0 degrees Celsius only. So, once again, what is happening to the heat provided? This is called as latent heat of fusion. So, here the heat supplied to the ice blocks or the ice cubes is used to break the bonds of the solid ice and convert it into liquid. Therefore, until the entire ice melts, there is no increase in the temperature. Increase in internal energy weakens and breaks the bonds between the water molecules in the ice. This temperature at which the ice starts melting is called its melting point. For water, it is 0 degrees Celsius. The heat required to convert 1 gram of solid completely into liquid at a constant temperature is called latent heat of fusion. Once again, the formula is the same, L is equal to Q by M. But latent heat of fusion of ice is 80 calories per gram. Children, we are looking into another concept now. Take a look at these images. What do you observe here? Yes, this is frozen coconut oil. We know that during winter season, the coconut oil that we use gets solidified, and this is solidified oil, olive oil. How is it possible, children, that liquids are getting converted into solids? This phenomena is called as freezing. The process in which a substance in liquid phase changes to solid is called as freezing. It happens because due to lower temperatures, it tends to lose some amount of its energy. When the temperature of a substance decreases, its internal energy decreases. The loss of internal energy is used to convert liquid into solid. So, where is the loss going, children? Yes, it is used to convert the liquid into solid. The temperature at which freezing takes place is called the freezing point. So, freezing point of water is 0 degrees Celsius. One more important point to note here is, children, density of ice is less than that of water. So, children, we have come to the end of the session. Now, let us have a quick review of what we have learned in today's class. The process of escaping of molecules from the surface of a liquid at any temperature is called evaporation. Evaporation is a surface phenomena. It is a cooling process. Condensation is a process in which gaseous particles convert to liquid due to decrease in temperature. Condensation is a warming process. Boiling is a process in which the liquid phase changes to gaseous phase at a constant temperature and constant pressure. The heat energy used to change the state from liquid to vapor is called latent heat of vaporization. Now, children, try to answer a few questions that are given here. Equal amounts of water are kept in a cup and in a dish. Which will evaporate faster? Why? Second question, why do we wear cotton clothes in summer? The next question, why do we store water in earthen pots? How can you say that ice is less dense than water? These are all application based questions, children, which you can solve very easily. So, children, I hope you have understood this class as well as the entire chapter. Happy learning, children. We have come to a conclusion of the chapter heat. In the next session, we are going to meet with more important concepts. Thank you, children.